The second and last thing that we're going to look at in Chapter 8 is a t-test. Just like with confidence intervals, we had a z-interval and a t-interval. The same thing's going to happen when we are doing a hypothesis test and we're talking about a hypothesis for mu, and we don't know the population standard deviation. When we didn't know it for the interval, we had to do a t-int, so now we're going to have to do a t-test. And I think almost the same type of question that we had for our t-int, we have, again, the head injury condition units for safety seats for child booster seats. So the safety requirement for the HIC measurement is that it should be less than 1,000. We're going to use a 0.05 significance to test a claim that the population has a mean less than 1,000 HIC, and do the results suggest that the child booster seats meet the specified requirements. You'll notice in here that we only have a list of data. It does not say anything about what's going on with sigma. We don't know the population standard deviation. So we're going to have to do a t-test. Our claim is that it is less than, oops, there we go, less than 1,000. That's our claim. The opposite of that, of course, is greater than or equal to, and we'll just say equal to, and so that must be my null. This must be the alternate. And what we're looking at as far as a curve is a less than, so a left tail test. So in here is going to be my red zone. Over in this direction is going to be 0.95 because this is a 0.05. My alpha goes in there. And so what we had a couple of options with the z-test, and we'll have that with also our t-test. Basically, what we're looking for here in a critical value is what t-score would have a cutoff where I'm going to have less than, or I'll have 0.05% of my data to the left. If I don't want to use the critical values, or it doesn't ask for critical values, we can just go ahead and use p-values. If they want to know both, then we're going to need to look up what this t-value is, and we're going to have to do that in the chart. This is a one-tailed test where the area to the left is a 0.05. We have a degrees of freedom is going to be, let's see, I have 6 and a 6. So DF then is 5. And so I pull up my chart if I can find it. And area in one tail is a 0.05. Degrees of freedom is also a 5. And so I come down here and I have a 2.015. Now, so it's going to give you the positive value. So you have to remember, if you're dealing with a left tail test, that you're really talking about the negative version. Notice also when we were in t-int, we always use this two tails and use the positive and the negative. If you have a greater than or a less than, you're only be talking about a one tail test. You got to look for that alpha up here on this top row and then say, okay, do I need the positive or do I need the negative? A left is going to be a negative. So over here, my cutoff is a negative 2.015. What I need now then is to either find my test statistic by hand or put it in my calculator and then compare that to my critical, or I have to start talking about p-values. I don't have all the information that I need to plug into my data, my formula, so I'm going to use my calculator, and you have two options here. Either way, you're going to have to go into stat, edit, and then we're going to have to put into L1 the data that's given to us. So 715, 694, 1005, 553, 533, 535, 514. I have stuff in my L2. I'm just going to leave it. I don't really have any issues with L2. So we're just going to look at L1. Now, I could either go to the main screen and run one vars and get out S of X, my sample standard deviation, and X bar, and plug it into the formula, or I can go into stat, over to test, and you'll see the second one there is t-test. We used z-test in the last one. Now I got t-test. Before, I always had the statistics and I was just going ahead and putting everything in. Now I actually have the hard data. And so I'm going to leave this highlighted and it will, for you, go to list one, crunch the numbers, and pull the X bar and the S of X for you. You don't need to run one vars, write it down, and then come in here and enter it. It will take care of all of it for you. So all I have to do is put in my information. My number in my null is 1000. The symbol in the alternate is less than. And I hit calculate. And I have a t that's a negative 4.35. So I am like way down here for the test stat. So I'm definitely in the red zone, which means I'm going to reject the null. The other thing, if I didn't know, of course, this value right there, I could look at this p-value and say 0.003 is certainly less than a 0.05, so I know I'm in the red zone, right? Because that would be from negative infinity up to this test stat. That would be the area under the curve. Either way, I reject the null, so he goes. That's good news. There's sufficient evidence to support my claim. So I'm going to put all of this now into MyMathLab and see what they're looking for. And you can see it asks for the test stat. We'll pull it up. Negative 4.36. It wants the p-value, 0.0036. Now it asks for the critical values, which of course you realize down here it does not give to you, but it does give you that x bar and that S of x. For the critical values, you had to go to the chart. You needed to do this process right here to get that negative 2.015. If it's a two tail, you'll have 2. If it's a one tail, you will have 1. And now we can go ahead and say, well, let's reject a null. There's sufficient evidence to support my claim. These critical values that sometimes they ask for and sometimes they don't, these guys right here, that is always an inverse norm or an inverse t situation. If you have an inverse t, I do. Maybe you do too. It would be under distribution. Ooh, and there, where's, oh, I thought I had an inverse t. Not on this one. Sometimes I have it, sometimes I don't. I guess it just depends on where I'm looking for. You can use inverse t sometimes. And then you can put in the 0.05 and then your degrees of freedom. Or, of course, you can use your lovely chart, which quite frankly is going to probably be easier than fighting with your calculator in that method. For the question, it says, does it meet the requirement? Yes, because we rejected the claim and we rejected the null and which supported our claim. So then we're good, even though this one is greater than allegedly these booster seats are safe. And that's how you do a t-test.